Hello children, let us understand empirical and molecular formula of a compound. Empirical formula represents simplest whole number ratio of various atoms present in a compound, whereas molecular formula represents the exact number of various atoms present in a molecule of a compound. Suppose in an experiment it is found that carbon, hydrogen and oxygen react in 1:2:1 ratio by weight to form a compound. Then empirical formula of the compound will be given by CH2 and the molecular formula of the compound will be given by C6H12O6. Means in a molecule of glucose there are 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. Quite clearly the common multiplier is 6. Common multiplier N is given by molecular weight of the compound upon empirical formula weight of the compound. Let us solve one numerical based on it. A compound contains 24.27% carbon, 4.07% hydrogen and 71.66% chlorine. Its molar mass is 98.96 gram. What are its empirical and molecular formulas? Suppose mass of compound is 100 gram. So mass of carbon is 24.27 gram. Mass of hydrogen is 4.07 gram and mass of chlorine is 71.66 gram. Now we will calculate the number of moles of carbon, hydrogen and chlorine. Number of moles of carbon is equal to mass of carbon upon atomic mass of carbon. That comes out to be 2.021. Number of moles of hydrogen is equal to mass of hydrogen upon atomic mass of hydrogen. That comes out to be 4.04. Number of moles of chlorine is equal to mass of chlorine upon atomic mass of chlorine. That comes out to be 2.021. Now divide all three by the smallest number among them. So smallest is 2.021. When you divide all three, that comes out to be 1, 2 and 1 respectively. So ratio of carbon, hydrogen and chlorine by weight is 1:2:1. So empirical formula will be CH2Cl. Now let us calculate empirical formula mass. So it will be 12.01 into 1 plus 1.008 into 2 plus 35.453 into 1. That comes out to be 49.48 gram. It is given that molar mass is 98.96 gram. So common multiplier N will be molar mass upon empirical formula mass. That comes out to be 2. So molecular formula of the compound will be C2H4Cl2. Now let us see density. Density is of two types, absolute density and relative density. Absolute density is equal to mass of substance upon volume of the substance, and relative density, as the name suggests, it is with respect to some substance. So let us see. For solids and liquids, absolute density is equal to mass upon volume, and relative density, which is also known as specific gravity, is equal to density of the substance upon density of water at 4 degrees centigrade, and density of water at 4 degrees centigrade is 1 gram per ml. For gases, absolute density is equal to molar mass upon molar volume. Relative density, which is also known as vapor density. So vapor density is defined as the density of the gas with respect to hydrogen gas at the same temperature and pressure. It can be calculated with respect to other gas as well. Formula for vapor density is equal to density of gas upon density of hydrogen gas. Vapor density is equal to molecular weight of gas upon molecular weight of hydrogen gas, and this is 2. So molecular weight of gas is equal to 2 times of vapor density. Let us see a couple of numericals based on density. First question is, what is the density of oxygen gas relative to sulfur dioxide gas under the same temperature and pressure? Density of oxygen upon density of sulfur dioxide is equal to molecular weight of oxygen gas upon molecular weight of sulfur dioxide gas, and that is 16 into 2 upon 32 plus 16 into 2. That comes out to be 32 upon 64, that is 1 by 2, and that is equal to 0.5. Second question, calculate the vapor density of a gas if its density is 0.2 gram per liter at STP. We know that weight of 22.4 liter of a gas at STP is known as its molecular weight. So molecular weight of the gas is 22.4 into density, that is 0.2. That comes out to be 4.48 gram. So vapor density of the gas is defined as molecular weight of the gas upon molecular weight of hydrogen gas. So it will come out to be 4.48 upon 2, that is 2.24. Now let us see gravimetric analysis. It is a method of quantitative analysis in which desired constituent is converted into a substance of known composition that can be separated from the sample and weighed. For example, in a chemical reaction, if precipitate is formed, that can be separated from the sample and weighed. We will see four types of numericals based on gravimetric analysis, and they are mass analysis, mass volume analysis, mass mole analysis, and volume analysis. We will see one question on each. First one is mass analysis. Question: an ore contains 2% of Ag2S by weight. How many grams of this ore has to be processed to get 1.5 gram of pure silver? Atomic mass of silver is 108 and that of sulfur is 32. First we will calculate molecular mass of Ag2S, and that is 108 into 2 plus 32, that is 248 gram. So out of 248 gram of Ag2S, silver is 216 gram. So we will form our logic here. 216 gram of Ag is present in 248 gram of Ag2S. So 1.5 gram of pure silver is present in how much of Ag2S? Second statement we will form from here. Since 2 gram of Ag2S is present in 100 gram of ore, as 2% of Ag2S is present in ore by weight, means 100 gram of ore contains 2 gram of Ag2S. So that's what it is written here. 2 gram of Ag2S is present in 100 gram of ore. So this much of Ag2S is present in what amount of ore? That comes out to be 86.11 gram of ore. Now let us see mass volume analysis. Question: how much calcium carbonate of 90% purity would be required to prepare 2.24 liter of carbon dioxide at STP when calcium carbonate reacts with dilute hydrochloric acid? The balanced chemical equation is given by CaCO3 plus 2HCl makes CaCl2 plus H2O plus CO2. It is clear from this equation that 1 mole of calcium carbonate produces 1 mole of carbon dioxide gas. Carbon dioxide gas that needs to be produced is 2.24 liter. We know that volume of 1 mole of any gas at STP is 22.4 liter. So number of moles in 2.24 liter of carbon dioxide will be 2.24 upon 22.4, that is 0.1 mole. So 0.1 mole of carbon dioxide will come from 0.1 mole of calcium carbonate. So mass of 0.1 mole of calcium carbonate will be 0.1 into molar mass of calcium carbonate. So it is 0.1 into 100, that is 10 gram. It is given that sample is 90% pure, means 90 gram of pure calcium carbonate comes from 100 gram of impure sample. So 10 gram of pure calcium carbonate will come from 10 into 100 upon 90 gram of impure sample. So that comes out to be 11.11 gram of impure sample, and that is the answer. Now let us see mass mole analysis. Question: calculate the number of moles of oxygen that will react with 8.5 gram of NH3. Balanced chemical reaction is given as 4NH3 plus 5O2 makes 4NO plus 6H2O. It is clear from this equation that 4 moles of ammonia reacts with 5 moles of oxygen gas. Number of moles of ammonia will be equal to 8.5 upon molar mass of ammonia, and that is 17 gram. So number of moles of NH3 will be 8.5 upon 17, that is 0.5. Since 4 moles of ammonia react with 5 moles of oxygen, so 0.5 moles of ammonia will react with 0.5 into 5 upon 4. So that is 2.5 upon 4, and that is equal to 0.625 moles of oxygen, and that is the answer. Now let us see volume analysis. Question: 10 ml of liquid CS2 is burnt in oxygen. Find the volume of the resulting CO2 at STP. Specific gravity of CS2 is 2.63. Balanced chemical equation is given as CS2 plus 3O2 makes CO2 plus 2SO2. That means 1 mole of CS2 produces 1 mole of CO2. Volume of 1 mole of CO2 at STP is 22.4 liter. Molar mass of CS2 is 76 gram. Means 76 gram of CS2 produces 22.4 liter of CO2. We will calculate mass of 10 ml of CS2. So mass of 10 ml of CS2 is equal to volume into specific gravity. Volume is 10 ml into specific gravity is given as 2.63. So mass of 10 ml of CS2 is 26.3 gram. Since 76 gram of SO2 produces 22.4 liter of CO2, so 26.3 gram of SO2 produces how much CO2? It comes out to be 26.3 into 22.4 upon 76, that is 7.75 liter of CO2. Now let us understand the limiting reagent. Many a times in a chemical reaction, the amount of reactants is different from the amount of reactants required in a balanced chemical reaction. In such cases, one reactant gets completely consumed, limiting the amount of product formed. Such a reactant is called as a limiting reagent. Let us see this question. For the reaction x plus 2y makes z, how many moles of z will be produced when 4 moles of x react with 6 moles of y? Also, find out the limiting reagent. It is given as x plus 2y makes z. It means 1 mole of x reacts with 2 moles of y to produce 1 mole of z. So if there are 6 moles of Y, they will react with 3 moles of X to produce 3 moles of Z. So Y gets completely consumed. Still 1 mole of X will be remaining in the reaction. So Y is limiting reagent and it will produce 3 moles of Z. In next video, we will talk about stoichiometric calculations and significant figures. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.